Gosh, don't you feel amazing right now? That stomping session in the courtyard was just amazing, right? No. How come? You feel that your shoes aren't sufficient at absorbing your stomping force and make it difficult to let out your anger? How come? I see. Well, looks like we're gonna need to get you some new shoes. In today's video, we will be finding Sasha a new pair of shoes that have better force absorption properties. The only question now is, what kind will he be getting? So we scrounged around the school in search of any shoes we could get a hold of. After a long and painstaking journey, we managed to find 3 top contenders. Number 1, Sasha's Crocs. But not cameraman Sasha, these Crocs belong to Mustache Sasha. Number 2, my UGG slippers. And finally, number 3, our physics teacher, Dr. Jack's Johnson Milans. So, now that we have a prime selection of shoes, let's find out which one will be the best at absorbing force. So, in order to determine which shoe will have the best force absorption properties, we will need to clamp our shoes. Let me introduce you to the guest star on today's video, the Pasco Mr. Thompson's Material Testing Compressing Machine. It's pretty cool. So pretty much how it works is you put your object in between these 2 material compression accessories, or just 2 hunks of metal. Then we're going to spin this handle and we're going to see a graph on this screen. Now, this graph right here is a position over force graph. The positions are in meters and the force is in newtons. Whenever we spin this handle, we're going to see a really cool looking graph up here, and it's gonna be awesome. So I'm gonna show you what it looks like right here. Let's record. And spin, 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 and come back. Awesome. Okay, you see this right here? This space right here in between these 2, this little space right here, this is exactly what we're looking for. So, you know, whenever you stomp on your shoes, it's kind of think of like memory foam. Whenever you press down on the memory foam, it takes a minute for it to spring back up. The same thing happens with your shoes. That is exactly what we're looking for in this video. The one that takes the longest to decompress, or the one with the most area right here, is the one that is the best at absorbing force. Here is our procedure. Place shoe upside down and press with metal pieces pressing down on the heel area and crank until the shoe is loosely secured in the mechanism. Start recording device on computer and start cranking. Crank the handle until displayed force equals approximately 750 newtons, then quickly change cranking direction until position equals 0. We proceeded to run this test on all 3 of our contending shoes. Here are the results from each test. So we have a lot of lines and graphs, but not a lot of answers. Do not click away yet, for the answers hide within. So this is the graph that came from our compression tests. As you can see, there are 2 lines stacked upon each other. Let's break those apart. In order to determine which shoe absorbs force the best, we will be using a mathematical concept that I came up with myself called Riemann's sum. So, in order to determine this, we need to find the area under this line right here. And this one, the downwards one. We find the area of this one and that one. Then we subtract the area of the downwards line one from the upwards line one, and then we will find the area in between what you saw on the graphs earlier, and that's how much it absorbs. So how will we go about finding this? Well, there's another concept in math which is using integrals, which is finding the exact area, which is using some very awesome, funny equations that involves knowing the equation of this line and this line. However, due to technological difficulties, we couldn't get those. So we did the next best thing and used my concept, Riemann's sum. Pretty much this is how it works. So instead of finding the exact thing, we use tiny, tiny, tiny little squares. Tiny, tiny little squares. So on and so forth to go all the way up. They'll be a lot smaller than this, but this is just so you can see them. So we find the area of these squares, and that will give us a close approximation as to how much the area of this line. We will repeat this for the other one, 2, you get the point. And then we will subtract this one, we'll call this one A, and this one B. We will do A minus B. That equals the good stuff. That equals this about here. And that will show us which shoe. It will show us how much the shoe absorbed. And then from that, we'll do that for all 3 of the shoes, and we will be able to determine which shoe absorbs all of the force the best. Future Alex here. I realized while editing this video that I have been mistaking my terminology. By subtracting the areas beneath the 2 lines, we are actually finding how much energy is absorbed by the sole of the shoe after being compressed. This energy, otherwise known as work in physics, is measured in units called joules, which are equal to the force of 1 Newton acting through 1 meter. The areas that we are about to find will be in this energy unit. So, in the case of this experiment, we are actually trying to find the amount of energy, or squish, that is retained by the sole of the shoe after being compressed, not the amount of force. Now back to your regularly scheduled lecture. So we know what we need to get from the graphs, and thanks to the Riemann sum, we know how to get it. Now, all we have to do is take the data points from the compression graphs, throw them into a Google Sheet, and work some math magic. Let's use Dr. Jack's shoe as an example. First, we have to split up the dataset into 2 smaller datasets that represent when the shoe is compressing and when it is decompressing. Next, we'll apply this formula to each of the 2 datasets. This will find the area of each of the tiny Riemann squares. Then, once we have all of the Riemann square areas, we will use this formula to find the Riemann sum for both of the datasets. Finally, once we have the Riemann sum under both the compression line and the decompression line, all that is left to do in order to find the energy absorption for Dr. Jack's shoe is a simple subtraction equation. After repeating this process 2 more times, we now have all the information we need to determine the most effective energy absorbing shoe from our selection. Here are the results. As you can see in this table, my UGG slippers proved to be the victors of this experiment. Absorbing approximately 89.22% of the energy exerted on them, we have finally found Sasha a new pair of shoes for stomping. Now that Sasha has new shoes, we can both stomp in peace. Yippee!